First things first, it's time to shake ground in the 8th round. Box battle will break down for the beat in the rock tone. Jumping the cyclone, S-C-Y-L-E, yes.
Attention Patrol Division, we have reported at least one mobile Code 6 driver followed by police.
I need all available units on this. Get them going Code 3.
Vehicle west BCB. Squad should be set up in the surrounding area.
Hey, there's something wrong with your ride. You left a huge oil slick at the start line. You have to end the race fast.
did I tell you?
Razor, he shadowed me. I couldn't shake
Shut up. Another bolt-on Wonder Boy looking to get smoked. Why don't we save you the grief and peel those parts right now?
Bolt on or not, that ride is hot. Faster than anything here.
You obviously don't know your cars, sweetheart.
I know your ride doesn't have a chance.
My 60-footer, quarter mile, whatever you want to throw on the table, smokes anything here, including this pump gas kit car.
Well, then where's your punk money then?
$5 grand. $5 grand. Says my boy'll smoke this clown.
What's your boy have to do with this?
I ain't racing this nobody. And I ain't taking orders from some chick who just rolled onto the scene.
Yeah. This here is the number 15 guy on the blacklist. You got a lot of rep to earn before you get to run with him.
Thanks for the update. Are we doing this or what?
I got him.
Yeah, a bunch of code 6s just ripped past me. These guys are really booking it. Stand by. Dispatch, I need more units. Racers have split up. We're currently headed west on Highway 201. Hey, can you give me some help out here? This guy's all over the place.
Copy that, Bravo 4-2. I'm clearing units right now.
Well, look what the underground let loose. Let's see how good you do in the daylight. See you around.
What's up, poser? I'm glad you're putting it down out there. I really am, because I can't wait to get a crack at that ride. What? Didn't anybody tell you? You gotta put your ride on the line to run against a blacklist racer, and that is why people aren't stupid enough to do it. I'll be waiting.
How's your car running?
Paper. I need your pink slip. He's dangerous. Be careful. He'll swap paint if he has to.
First, I'm gonna take your ride, then I'm gonna...
Some racers trying to catch up to them now. I need to get a couple units in the area to be on the lookout for these guys. Details on DDT. That code 6 pulled away from me. I lost my visual. We're fine. I'm at the vehicles now. You guys don't look like they want to stop. Stand by. I got a chase here. Code 3, code 3. Cancel that. I have him in sight. Dispatch requests immediate cover for these Code 6 parties.
Roger that, 422. I've got ground units clearing up and en route.
A set of units for containment. I lost them. I need a 1083.
Remaining units, be advised, vehicle wet BCB. Squad can be set up in the surrounding area.
Hey, there's something wrong with your ride. You left a huge oil slick at the start line. You have to end the race fast.
Hey, do your thing. Hey, fresh out the house, got the beat. As I ride up and down Martin Luther King Drive, standing tall, looking down. Boy, snitching all day, I look around on the block.
I'm in a silver and sell 5 pound on the block. Ain't you ever seen a young player clown in the draw? Ain't nothing to a G. He spit fluently, groups pursuing me is it?
So you found it all right. What do you think? You can store your ride here. Consider it your safe house.
I am riding, no breaking me. I am riding, no shit.
Alpha District. We just received numerous complaints regarding a speeding vehicle that was last seen heading westbound on Campus Way. Can I get some units to head up?
Dispatch, you got any more info on that call?
Suspect in a silver Lexus.
I'll go ahead and head up. Traffic stop. I'm pulling over a speeder. Suspect vehicle is a silver Lexus. This guy is way over the limit. Driver knows what he's doing. He's giving me a hard time. Roll out cover units on this call and get me some help as quick as you can.
Roger that, Bravo 3-3. I'm clearing units right now.
There's no way he's stopping. I'm going to try to eat him over. That's point 1059. Continuing pursuit. Can we put together 1073? I'm not going to be able to stop these guys on my own.
10-10, Bravo 3-3. 5-1 is requesting we hold off on that roadblock. He's monitoring and heading Tier 20.
Yeah, these guys are splitting up. Let's go. We need more units.
Update situation.
Having a hard time staying with him. Code 6 causing me a lot of problems. We need to calm this guy down. Can you advise if we're clear to fall back? Pressure's making him cause a lot of damage out here. Yeah, we have a unit down here. Repeat, we have a unit down. He's turned off into the strip. I need all available units on this. Get him going now. Code 3. 370. Suspect without gas station. Notify hazmat. Code 6 lost. Now time delay. Let's go. I got him. Get everybody over here. Dispatch, code 6 party located. Reinitiating pursuit. Okay, he's going right through the gas station. Right through the station. Code 6, vehicle's gone. She's lost. Set up containment. Dispatch, Charlie 29, get fast ahead to business zone. This guy can't be too far. I'm on him. Let's get everybody over here.
Units heading up to the pursuit call. Be advised, suspect was last reported heading westbound past Diamond Park. Squad is to be set up around the immediate area. Remaining units begin patrol within the zone.
Bravo 29. Closing on a vehicle that just sped by me. Stand by while I attempt to stop. Suspect's in a silver Lexus. Speeds are way over the limit. That's definitely our guy, code 3. Can I get some backup over here? I can't get this guy stopped. Oh, look out, he's right on the brakes. just shut down. I need cover. Dispatch, get units set up containment. I lost him.
Units in the area be advised. The Code 6 suspect was last seen heading east on Highway 99. Quadrant has been authorized.
Come on,
chilling in the swamp like Artax, bossing the fear facts. Chill, watch Miramax flicks, then I start to get sick. Hail drop, 39 like the Hail Bob. 4 teachers, 1 meal. Cops in the atmosphere will get real.
Never gonna stop trying to get it, dude. Never turn my back on my city. Never let the money stop with me. I'ma never stop hollering at the sense go. And 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 I say sense go. And the two, you belong. And the sense go. Hey, homie, you don't wanna get familiar with us. Nigga, no, but you would give me and my rush. I'm sick of all you unfortunate supposed to be big with telling stories about your life when I was not how it was. Yeah, I'm sure 'cause this back in the days with the like in you when you was out there getting paid with the you get the when you hitting the days, it's not your beat. Go. Yeah, you know I'm from the know you, but you do not know me. When I ball and big it down for you, do not own me. You don't wanna know what I've been thinking of. You better go ahead on and find you another spot to chill, 'cause I've been dipping dust. We see a light and everything ain't great. It's like everybody's mind is in the same old state, you know? Although I knew I put in revenues.
sound system with Terry timing. I'm gonna try and catch up to him. Looks like these could be street racers. Let's get some units cleared.
Is that better? Is it working at least? Yeah, I see levels now. Okay, can we hear anything? Stupid fucking thing. Doesn't want to work. Of course. Ah. What are you doing? Why'd you go to fucking 1080, you piece of shit? Hmm. Blah, 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 blah. Should I just do like live? I should just do like a live dub over this guy. Welcome to Las Vegas, where we're going to charge you up the ass for a fucking graphics card. Yeah, share with me. You guys are going to like what we give you. Oh, no. Huh. I wonder why I'm not getting sound. I don't know what would be the cause of that. Actually, I do. Here you go.
Technology and conviction to drive innovation.
Conviction.
And reshape
Crime?
our industry and our society. I always like to say that if I'd listened a little bit more closely the last time Jensen spoke at a CTA event, I could have retired already. But over the past 3 decades, he has established Nvidia as a force.
Man, they couldn't give him a teleprompter in front of him? Jesus Christ, he's looking down at his shoes.
From healthcare to automotive and entertainment. Today, Nvidia is pioneering breakthroughs in AI and accelerated computing that touch nearly every person and every business. Thanks to his leadership, Nvidia's innovations enable advanced chatbots, robots,
oh boy,
software-defined vehicles,
chatbots,
huge virtual worlds,
thank you, Jensen,
hyper-synchronized factory floors, and so much more. Wang has been named the world's best CEO by Fortune and The Economist, as well as one of Time Magazine's 100 most influential people in the world. But you know, the fact is, like for all of us in this room, our success and his success was not preordained. Jensen started out working. I
was saying my prediction is 1,600 for a 5080, and I think close to 3,000 for a 5090. I hope I'm wrong, though.
The value of hard work, humility, and hospitality are what helped him keep the faith and persevere through some of NVIDIA's early challenges.
Why is he saying NVIDIA?
In just a few minutes, we'll hear from NVIDIA founder and CEO Jensen Huang on his unwavering vision of the future and where we're headed next. Stay tuned and have a great CES.
Get off the stage. Throw a tomato. I hate that girl on her tablet. These things are horrible. These events, sitting in that sweaty crowd. I've been to a couple like this. I went to E3 a couple times. Shut up. I went to E3 a couple times. I went in 2010, and we went to Nintendo and Sony's press conferences, and man, there was just a bunch of sweaty people in there. Sony had an open bar though outside. It was like 10 o'clock in the morning at an open bar. Silence your devices. See if we can hear what people in the crowd are saying. What is that? Got a fever. I should go get my I don't know, I should go get a bottle of liquor and rum or something. Take a shot every time they say AI. I'd probably die within the first 5 minutes. What is this? I feel like I'm in an elevator. It's like Moby's B-sides. There we go. Get ready. Except for the historical information contained herein, certain matters in this presentation are forward-looking statements. That means what you're about to hear is bullshit. The presentation contains several sequences of quickly flashing lights that may cause discomfort and or affect guests who are susceptible to photosensitive epilepsy or other photosensitivities. So be careful. Just a warning if you're epileptic. Not my fault. I want to see more from Nvidia. Nvidia. I just gave it away, but if he watches, he knows what it is. I know a guy who says Nvidia. He doesn't say Nvidia. He said Nvidia. It's like he can't help himself. That's just how he thinks it's said. Nvidia. What is that logo supposed to be? Like an eye or something. It's like an elf ear. They probably paid $50,000 to have this animation made. And just loop. For real this time, right?
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI.
Shot.
Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters.
Get out of here.
Inspire new ways to celebrate our victories.
A martini, please.
Hey, you know what's funny? These are all human jobs.
Thank you, Adam.
Fuck off.
And give us peace of mind when we need it most.
Don't give it names like that.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take a blood sample today, okay?
You and this creepy robotic freak are gonna have fun.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together.
Millions of jobs gone.
And here is where it all begins.
Put your phones down. People are obnoxious. Whole thing's being recorded.
Nvidia founder and CEO, Jensen Huang.
Jensen. There he is, the jacket.
Welcome
Ooh,
to CES.
That's a glossy jacket, man.
Are you excited to be in Las Vegas?
Is that are those sequins?
Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all.
5 people got that reference.
If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it.
Hour, man. I don't know about that.
Well,
sorry. I think I need to tweak my
fact,
limit.
you're inside NVIDIA's digital twin. And we're going to take you
That's fine. Whatever.
to NVIDIA. Ladies and gentlemen, welcome to NVIDIA.
Welcome to
You're
NVIDIA.
inside our digital twin.
Not NVIDIA? Sorry, I'm doing that. No? Wow.
It has been an extraordinary journey, extraordinary year.
So their video's crushed, not mine. Huh.
It started in 1993. Ready, go! With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter.
That's cool. I didn't know that.
6 years later, we invented, in 1999, the programmable GPU. And it started 20-plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could
Because we CUDA.
explain
I'm sorry.
GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works.
It's more than meets
today,
the eye.
Computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
Lovely YouTube compression. DLSS 4. Uh-oh. IGN can't handle it. YouTube can't handle it. It's not good. Hang on. It's crashing for everybody, apparently. Or lagging.
That was real-time computer graphics.
Okay, we're a little behind, but at least it might not buffer. It's just CES is
That
a official
was
channel.
real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the color should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate.
What?
What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33.
I thought he meant 2 pixels.
We're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence.
This skipping
and
is driving me
artificial
crazy.
Intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation.
No.
The RTX Blackwell family. Let's take a look.
Did anyone expect this? Well, they look just like the last ones. He just now decided the price.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders.
This means
one
nothing
is
to
performing
anyone
point,
watching
one is
this.
Integer. G7 memory from Micron, 1.8 terabytes per second, twice the
Okay, I'm about to go over to
last
another
generation.
stream. This guy's skipping is
And we now have the
terrible.
ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able these neural networks, and as a result, we
This is
invented
Nvidia's stream. This looks
neural
better.
texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090.
So that's pretty small.
Now,
It's a 5090.
even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one.
Wow. Look at that. Only $15.99 for the current one.
It's $1,599. It is one of the best investments you could possibly make. For $15.99, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled, fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $15.99, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance.
Whoa.
At $549.
Undercut. I mean, wow. Okay. That's impressive.
Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090.
Whoa, only $1,000 for a 5080 is actually surprising.
Of course, we're producing
only $1,000
at very large scale, availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a
$1,000 premium for the 5090.
For
That's insane.
This 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is look at this thing. Here. There's only so many pockets.
You're not going to find a 5070 or 5070 Ti for a year. They're going to get sold out in 5 minutes.
So can you imagine? You got this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay? So, ladies and gentlemen, the RTX Blackwell family.
That could have been a lot worse.
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at Nvidia. This is literally our office. This is literally Nvidia's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more
I don't know that he
compute
said.
you apply to it, therefore, the
Probably
more
12 gigs is my
effective
guess.
or the more capable your model will become. And so the scaling law
The rumor was
continues.
that the
What's really amazing
5080
is that
would
now
have
we're moving
16
toward,
gigs.
of course, and the
And I
internet is
think the
producing
5090 would have
about
32.
twice the amount of data every single year as it did last year. I think in the next couple of years we'll produce.
So I would bet if the 5080
humanity
has
will
16,
produce
I would
more
bet the
data
5070 is going to have
than
12.
all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback.
It's important to note, too, he did say with the power of AI, the 5070 delivers 4090 performance. So, like, not raw performance.
To refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems.
So, like, with DLSS 4,
and so it's essentially
they're
like
claiming it's 4090 performance.
Or having a coach give you feedback after you're done going to school.
But still,
So
I mean,
you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand. Maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate. Your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems.
Yeah, how are their stocks doing?
So, scaling law. It's driving enormous demand for NVIDIA computing. It's driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some...
That's a big screen.
Every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that
I can't get over that jacket, man. It's so distracting. The stock's up 3.5% today, so.
It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea? All right.
Don't applaud that. Please don't applaud this.
Wait for it. Wait for it. I thought I was worthy. Apparently, Yonir didn't think I was worthy. All right. This is my show and tell. This is show and tell. So,
this is worse than Miyamoto with
system,
that Master
right
Sword. I know.
This NVLink system. This is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts.
Kilowatt?
It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables.
Come on, a lot of Bitcoin with that.
This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost.
What is the point of the shield, dude?
These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now, the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry, guys. You see that? That's cool. Look at that. Disco lights in here.
He's blinding the crowd.
If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield.
Okay.
It would have to be probably 3 or 4 times this size.
Finally.
But what we basically have here is 72 Blackwell
Finally,
GPUs
the example is
144
explained.
dies.
Jesus, that
This
took 10 minutes.
Chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips.
What's the energy consumption of this?
130 trillion.
What is this doing to the Earth's environment?
2,592 CPU cores.
Jesus.
Whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible. Okay.
Good Lord.
And these are all of the HBM memories.
Blind everybody.
14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made.
Somebody raided a Michaels and just put this thing together today.
In addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can... Thank you. Thanks.
It's like, nice work with the...
Boy, is there a chair I could sit down for a second?
Getting old, Jensen.
Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to Nvidia and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models, and these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting. They're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high.
It's like we've never seen Terminator.
The token generation rates to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created three
Digital
things
human.
for helping the ecosystem build agentic AI. Nvidia NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or they might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee.
Mr. Anderson.
And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process is different. The way you work is different. So you would give them examples of what the work product should look like. And they would try to generate it, and you would give a feedback. And then you would evaluate them, so on and so forth. And so and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say.
Oh, that'll work.
And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama. the Nvidia Llama Nemotron language foundation models. Llama 3.1
Nice.
is
Winamp
a
returns.
phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small.
I wish I was an engineer, man. I don't know what he's talking about.
What we call super, Llama Nemotron Supers. They're
No
basically your mainstream versions of your models. Or your Ultra model. The Ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not.
How will it
Basically
affect
give feedback to other models?
Alan Wake
It could
2?
be distilled in a lot of
Just
different
like,
ways. Basically, a teacher
bring it
model,
back.
a knowledge distillation
It's reality here.
Model. Very large, very capable. And so all of this is now available online. Well, these models
Will it finally
are
fix
incredible. It's
Jedi Survivor?
number one
That's
in
what I want to
leaderboards
know.
For chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry.
Siemens.
We have great partners and really
Oracle.
great work being done
I know
at
some of
ServiceNow,
those
at
companies.
SAP, at Siemens, for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized
Perplexity.
search. Yeah, really fantastic
Cohesity.
stuff.
Cloudera.
Codium, every software engineer in the world. This is going to be the next giant AI application. Next giant AI service, period, is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents. AI agents are the new digital workforce, working for and with us. AI agents
And against
are a
us.
system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response.
They gave him
NVIDIA's agentic
like an
AI
Xbox
building
avatar. What is
blocks,
this?
Pre-trained models and NEMO framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees.
His AI.
AI agents
He
are
looks high as shit. Look at him.
domain-specific task experts. Let me show you
Yep.
4 examples.
Yep.
For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with
Well,
a
that's
diffusion
creepy as
model,
shit. That doesn't look good at all.
Downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers
What was
like at
that?
Nvidia manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents built on an NVIDIA Metropolis blueprint.
Yeah, no
including
kidding.
NVIDIA Cosmos
Looks like it, doesn't it?
Nematron
Looks like a
Vision
David
language
Cage
models,
game.
Llama
This is the
Nematron
5090?
LLMs, and NEMO Retriever.
Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting.
But can't help you physically.
And help monitor traffic flows.
Oh, that's stock footage. I've used that
danger.
before.
In industrial facilities, they monitor processes and
Oh,
generate
man.
recommendations.
What a
for
nightmare.
improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization.
God, this is gonna
Okay.
make me quit my job.
That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI was created in the cloud and for the cloud. And for enjoying AI on phones, of
Got any
course,
other
it's
looks?
perfect. Very, very soon.
That'd be hilarious if the only available option ever is Jensen.
And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud. It's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMS, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and Nvidia NIM, an artist can quickly realize their vision.
Or they can take a fucking picture.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you.
Cool. Yeah, they're not that impressed,
The
bro.
next is good.
You're killing jobs here.
Okay, let's talk about physical AI.
Let's.
Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token.
Autobots
so
or
you could have
Decepticons?
Hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if, instead of PDFs, it's your surrounding? And what if, instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today, we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an Nvidia CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could
I want them to train an AI model in Cosmos with Jackie Chan movies.
Distill it and
that would be
into
fucking awesome.
The beginnings of a robotics model. You could have it generate multiple physically based, physically plausible
an AI that does its own stunts
of the future. Basically, do a Doctor Strange. You could because this model understands the physical world. Of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models.
Crazy.
So this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth
Robot
that
AI.
can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are
All
really
the Marvel
quite
fans
exciting.
just perked up.
And of course,
Multiverse?
For robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is.
Somebody got up.
These computers are at the edge, and they're autonomous.
Jensen's
But
testing
to connect
people's
the
bladder
two,
strength
you need
now.
a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics. So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Keyon, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners, and we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Keyon and Accenture.
Keyon, the supply chain solution company, Accenture, a global leader in professional services, and Nvidia are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Keyon is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Keyon's warehouse management solution assigns tasks to the industrial AI brains
All right,
in the
I'm about
digital
to
twin,
dip.
such as moving a load from a
I'm
buffer
about to
location
dip out of this.
to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse.
Let me know if this is
digitalized into Omniverse
intriguing to you. Otherwise, I'm
using
gonna
OpenUSD
go play
connectors
something.
to aggregate CAD, video
Too much
and
going
image
on.
to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin
Wow,
environment.
Nvidia's YouTube channel is
planning
almost
their
2
next
million
motion
subscribers.
and
That's
acting.
surprising.
The robot brains can see the resulting state through sensor simulations and decide their next action.
Okay.
The loop continues while Mega precisely tracks the state of everything in the digital twin.
So I'm gonna.
Now, Keon can
I
simulate
mean, we're almost done.
infinite
Probably.
scenarios
It's another
at scale
probably 10 minutes.
while measuring operational KPIs,
The gaming portion's over.
such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with Nvidia, Keon and Accenture
Jensen, you're putting
are
me to sleep,
reinventing
bro.
industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic
I will
data
never be
generation
comfortable with
systems, Omniverse, and now
AI
Cosmos,
driving me
and
in a
also
car.
the computer that's inside the car. Each car company might work with us in a different way.
I don't think
There's
I'll ever
one or
hit that
two or
level of
three
comfort.
computers. We're working with just about every major car company around the world. Waymo and Zoox.
All right, I don't care about this. I'm gonna hook the 360 back up. Be right back. All right. A little more most wanted before I go to bed. There she blows. All right. I finished second. Restart. Let me make sure the what do you call it? Black levels are set correctly. I screwed with them because I thought that stream was messed up. That looks better. Actually. Now my TV's off. 1 second. Brightness adjust. It's on auto. I don't think it works right. Okay, that's better. Alright, much better. Now I can see. Thank it. Thank you. All right, what else we got here? Oh, that's the other guy. Hang on. There we go. Let's do a knockout. Heh, I got no music on here. So I'm gonna be doing I'm gonna soft mod a original Xbox on Wednesday. Should I live stream that? I got the parts coming in Wednesday, so let me know if that's something worth streaming. I don't know. I'm not very good with that stuff, but it's pretty easy to do. Just follow a guide. That's what I'm gonna do. Going. Good grief. Pay attention. Sorry if y'all are coming here because the title says Nvidia Keynote. I stopped watching it and it stopped talking about game stuff a while ago. But if you like watching Need for Speed Most Wanted on a 360 with the Blades interface, check that out, right? You'll see that every day. You come to the right place. Oh, he's gonna take that shortcut. Oh, he missed it. Good. Oh, crap. There we go. Got him.
Counter be advised. 911 callers are reporting multiple vehicles racing. Suspects were last seen westbound on State Street. Units in the area on non-primary
Westbound on State Street. Alright. Let's see what other events I got here. I got a sprint. I got a toll booth. I'll save the toll booth for last. That's easy. They're dropping like flies, Captain. Oh, look at that. Whoops. Home stretch.
Patrol division, be advised. We got multiple complaints about a reckless driver who was last seen westbound. Units in the area to respond.
Can you give me more info on that call?
Alright, let's see, how much bounty do I need? I need 50,000. I got 28 now. It's not much. Let's do a couple of milestone events. Okay, this is easy.
Dispatch, 026. 1096, as soon as I catch up, second. Suspects in a silver Lexus. Traveling way over posted speed limit. Yeah, confirm he's running. Code 3, I'm in pursuit. Hey, can I get some backup over here? I can't get this guy stopped.
Copy that, Sierra 26. I'm clearing units right now.
I'm in the containment. The vehicle got away. Dispatch vehicle located. He's running. Suspect heading east on State Street. I'm having a problem here. Just hold. Yeah, I got a problem with the car. Just shut down. I need cover. Yeah, I got it. Vehicle located.
Ooh.
I'm gonna try to get him stopped with a 1059.
Wow, I've only got 850 bounty so far. 950. There we go.
He's not stopping. Still go through.
What was that?
Bravo 35. 1023 on scene. Suspect through the campus. He's pulling away. I'm trying to maintain visual.
Drama.
Sierra 19. Can you advise on your situation?
He's getting through the park. He's onto the trails. PCB closing in on his last known direction. I have visual. Code 3. I'm gonna try to get in front of this guy, slow him down. I need more cover. Repeat, more cover. I lost a unit. 1033, we need me.
have to hang in there. Backup is still at least a few minutes away.
Charlie 2-4 just has chase with some other units standing by. We'll be ready.
2-7, copy. Likewise, I got units on my point. We're coming in hard and fast. Also code 3.
Speaking of crash. Oh, found me.
Vehicle located. Do you have any other in the area? I'm on my own.
Yeah, your cover is inbound, but they're a few miles out.
Charlie 2-4, couple miles out.
Uh-oh. Cover's on the way.
29, just off that guy's border, closing.
Excuse you. You can straighten up, bro. It's alright. Hey, come follow me through here. It didn't get him, but it stopped him a little bit. Nice, he's on me again. Dang it. Alright. Uh-oh. Just leveled up.
Units are a couple miles away.
Code 6, party lost. I need a quadrant set up ASAP.
Units in the area, be advised. The Code 6 suspect was last seen westbound past Boundary Mall. Supervisor requesting you set up a quadrant ASAP. Units remain on Code 6 status till further notice. 10-4 dispatch. This is Bravo 27 requesting air support. This is a big zone to cover.
Dispatch 2 on the 12. Can you update a file on info on file? My screen just went down. I lost everything.
Suspect is 1032, but he's not on Code 6.
4100.
Anyway.
Oh, I can challenge him. I still got the... Well, not that guy. I still have the other toll booth race I want to do. I like the toll booth race. These are fun. There's no other racers, so it's just kind of a chill experience. That's a nice effect. The fog on the road like that. That's kind of cool. I'm so glad I found this version of the game. Good lord, I'd looked for it forever. Walk in the store, bam, it's right there. I was like, what? Okay. Well, I can't not buy it. But to throw salt on the wound, someone traded in a crap ton of Dreamcast games over the weekend, and I had to pick one out of like 5 that I wanted because they were like $80 a piece. Crazy. I went with Resident Evil Code Veronica, so I picked that. They also had Shenmue, Jet Grind Radio, Marvel vs. Capcom. Like, I was like, man, I'm probably gonna go back and get Marvel vs. Capcom. That's a really hard to find one. If it's still there, I'll probably end up picking it up. I'm not really even that into fighting games. It's just I know a rare game when I see it. There it is. Easy peasy. Alright, let's do the rival. Get out of my way. Good fucking Lord. It's like it's magnetically sealed to me. Good thing we're only 40% done with the race. One down, one to go. He's racing my car, right? He has a Lexus. Yeah, an ugly, tricked out Lexus. is mine. It's either this one or this one. Got it. Move to the left. Vic.
Ready to go. You're in.
Great. All right, I'm gonna play a couple of races of Sega Rally Revo, and then I'm gonna go.
I'm impressed. Daz underestimated you and paid the price. Make sure you never do the same. I'll hook up with you later.
You might want to see this, right? Seen this interface in a while. How about that? All right.
Sega.
There it is. That's the controller. That's a noisy disk drive.
3, 2, 1, go! Easy left. Long, easy right.
Man, them load times are terrible. Holy crap. Whew. It's faster on PS3. A lot faster in RPCS3. Take a nap in these load screens. Good lord. Let me check my email. All right, here we go.
Three, two, one, go! Easy right, maybe. Medium left, medium right. Over jump. Long, easy left.
Easy left. What?
Easy right. Medium left. Over jump, maybe. Medium left, medium right, maybe.
These are medium turns? These are like freaking 90-degree turns. Anyway.
Easy right, easy left.
Quit complaining.
Very long, easy left. Hairpin left, maybe. Hairpin right. Hairpin left. Easy right, maybe. Medium left, medium right. Over jump. Long, easy left. Easy right. Medium left. Over jump, maybe. Medium left, medium right, maybe. Easy right, easy left. Very long, easy left. Hairpin left, maybe. Hairpin right. Hairpin left. Easy right, maybe. Medium left, medium right. Over jump. Long, easy left. Easy right. Medium left.
Terrible.
Over jump, maybe. Medium left, medium right, maybe. Easy right, easy left. Very long, easy left. Hairpin left, maybe. Hairpin right. Hairpin left. Finish.
All right, one more race. Oh, that was it. Good, never mind. Unlocked a new livery. All right. All right, I think that's going to do it for me tonight, guys. I'm tired. I'm going to go to bed. I'll be on tomorrow. 8 p.m. Eastern. See you then. Have a good one.